Hi,
Hello guys, how are you?
fine. Miss, do
Hi.
we have two sessions?
Yes, we
Yes.
do. Mute your mics, please. Please mute your mics. Judy, mute your mic. Thank you. We are waiting for people to come in. How many were you in the last session, guys?
15.
15. Okay. Okay. So we are going to hopefully finish all of the heat lesson worksheets today, the remaining ones. So I want you to open page 58, please. Open page 58.
Miss, will we correct the homework today?
I am doing this right now.
Okay.
Page 58. Would you please text the
Miss,
rest
page
of
what?
the class? 58. Please text the rest of the class so that they can join us.
Okay.
All right. So in page,
I think they went.
you think what?
I think they went into the English because when I was joining the science, like it was green to join the English. So I think they don't know that the
All
English
right.
is cancelled.
Would you, if you can send them on WhatsApp or something, please do so. Tell them that they have science, they don't have English, okay? Okay, so in worksheet 10, this is page, all right, thank you, dear. Page 58, class 6H, want to find the best cup to keep drinks hot. So as I told you, you will find that all the worksheets related to the heat lesson, it is mainly focuses mainly on the heat or thermal conductors or insulators. Those are the most questions. So they want to keep, please do not use the chat. Please don't, if you want to say something, raise your hand and I will give you the permission to talk. Okay, yes, Mira, do you need something?
Yes, I just wanted to answer.
Okay, dear. Anyone else need anything?
No.
Okay. Class 6H1 to find the best cup to keep drinks hot. Tick one box to show which property is most important when choosing the best cup to keep a drink hot. Yes, Mira, what is your answer?
Insulating.
Yes, you're looking for an insulating material to cover the cup with so that the drink stays hot. All right. Question B, the class used the cups shown below. The cups are all made from the same material. Okay, so the cup itself is made of the same material. What we covered the cup with, this is what is different. Okay, so let's check. I just need to go down a little bit. So you have 4 types of cups: cup A, cup B, cup C, and cup D. Write A, C, or D each row of the table below to show which cup gave each set of results. Now cup B has been done for you. Okay, so right here, cup B, once we poured the liquid inside, the liquid was 70 degrees Celsius. After a while, it became 49 and then 40. How did we know that this is cup B? Because this is the cup, since cup B is not covered by anything and it's thin, so you will find that the drop in the temperature is very high, from 70 to 49 to 40. Okay, so now what do you think will be the rest? Write A, C, and D. Only Mira knows where are the rest of the people. Raise your hand, please, if you want to answer. Did you do the homework, guys? That was a homework.
Yes.
Okay.
Miss, can I?
Miss, I was raising my hand.
Okay. Ahmed Hatem.
Okay. The first one is D. Second A. Last. Before,
Yes, and the third one?
Before B is C.
Okay, so first you said D, then
Yes.
A,
Then
then C. Very good. How did he, or why did he choose this sequence? Because first of all, you have D. D, you will find that they only did not use a thick cup. They did not only use a thick cup, they even covered it with an insulating material and they put a cover on it. So the first thing, that the cup itself was thick, not thin like B. And the second thing, that we even covered it with an insulating material, and then we covered it with a cover. We put a cover over it. So this is why it's going to be, the first one is going to be D, which you will notice that the temperature is decreasing or is reducing gradually from 70 to 64, then to 60. It's really the small, very small decrease or very small reducing in the temperature is happening. The second one is cup A. And why did he choose cup A? Because cup A, we used a thick cup and we covered it with another insulating material. And this is why it is going to drop, the temperature is going to drop not as slow as D and not as fast as B or C that we're going to write next. So write the next one is C. And how did we know? Because we find that cup C, they only used a thick cup. They did not cover it with an insulating material, and they did not cover it with a cover like cup D. So this is why the drop in the temperature will be a little bit more than A and D. Do you understand, guys?
Yes.
All right, guys. So let's move to the next question in page 59. Now we're doing page 59. Okay. In page 59, question C, look at the pictures of the cups. Cup B cooled the quickest. Explain why cup B cooled the quickest. Yes, Nancy.
First, because it is opened and has a thin wall.
Very good. It is opened, it's not covered, and it has a thin wall. Very good. Okay. Because it is, because it is opened and has a thin wall. Thank you, Nancy. The next one is, this is a graph, guys. Have you ever dealt with a graph before in the math, or
Yes.
you know how?
Yes.
Okay. All right. You were dealing with bar graphs, maybe?
Yes.
Yes. Okay. This is called a line graph. Okay. There are several types of graphs, a lot of types of graphs, and you should now get used to it until you reach year 6. It's going to be advanced. So you have to know how to read a graph so that you can be able to read a more advanced ones. Okay. And this is why I asked you guys to answer the worksheet, the practice worksheet, so that if you are a little bit confused about the graph, because there is a graph there, if you're confused about the graph, I can help you with it. Okay. So this is called the line graph. And how do we use this graph? Here in this graph, the class measure the temperature of the drink in one of the cups for a longer time. So they chose one of the 4 cups and they started to notice how the temperature is going to drop during or as the time passes. Okay. So if you looked at the previous table, you will find that all of the drinks, all of the cups at 0 minutes, which means that once we started to record the drop in temperature, what was the first temperature of the drink? What was the temperature of the drink, guys? Anyone?
I know.
Okay, at the beginning of the experiment, what was the temperature of the drink? Yes, Mira. Mira, are you there?
Miss, can you hear me?
Now I can hear you. Unmute yourself, dear. Unmute your mic, Mira.
Miss, I'm unmuting my mic. Can you hear me?
Yes, now I can hear you. What is the temperature at the beginning of the experiment?
70.
70. So this is why we said here we write the time. This is called this line is called the x-axis, and this line is called the y-axis. Okay, so we put what we are going to change, or the things that we're going to measure and the things that we're going to change in both of those axes. Okay, in this line I'm going to put the time in minutes, which means that every how long am I going to measure the temperature. So right here, I put first at 0. So this is the beginning of the experiment. And then after 30 minutes, and then after 60 minutes, and then after 90 minutes, and then after 120 minutes, and then after 150 minutes, then after 180 minutes, and then after 210 minutes. So this is the interval, or how long am I going, or every how many minutes am I going to record the temperature. Okay, and in the y-axis I recorded, or I put all the temperatures from 0 to 80. Each box represent 10 degrees Celsius. So here you have 0 degrees Celsius, then 10 degrees Celsius, then 20 degrees Celsius, then 30 degrees Celsius, then 40 degrees Celsius, then 50 degrees Celsius, until you reach 80 degrees Celsius. Okay, now let's see what did they do. Okay. First, the drink at the beginning of the experiment, we know that it was 70 degrees Celsius. So this is at 0 time, at 0 minutes, right as we started the experiment. The moment that we started the experiment, this we consider 0 minutes. Okay, so what was the temperature? It was 70 degrees Celsius. So I put an X at the 70 degrees Celsius. Okay, I go up from 0 to 70. All right. Now, then they measured the temperature after how many minutes? After how many minutes did I measure did I take the second reading? Yes, Nancy?
150.
What?
150.
150, how, dear? After how many minutes did I take the second temperature reading?
30.
Yes, after 30 minutes, I took the second temperature. So
I
what?
thought you said when it stopped cooling down.
All right, no. I was saying after how many minutes did I take the second reading? After 30 minutes. And after 30 minutes, Nancy, what was the drink temperature?
40.
40, excellent. So what Nancy did is that she went up from 30 and she saw that we put the X in front of the 40. So this means that the temperature after 30 minutes became 40 degrees Celsius. Very good, Nancy. Ali, the third reading was after how many minutes? Ali.
Third reading was after 1 hour, 60 minutes.
60 minutes or 1 hour, exactly. And what was the temperature then?
The temperature then was 30 degrees.
Was 30 or above 30 a little bit?
Like 30 something.
Yes, like 32 degrees Celsius. Okay? Okay, thank you. Next, Ruqayya, are you there? Ruqayya. Is Ruqayya there, guys? No, I don't think she's here. Okay, let's take Hamza. Hamza, whoever's mic is unmuted, please mute your mic. Hamza, are you there?
Yes, miss, do you hear me?
Yes, dear, I hear you. Now the fourth reading was after how many minutes?
1 hour and 30 and 1 hour and 30 minutes.
Which means 90 minutes. Yes, 90 minutes.
Yeah.
And what was the temperature at 90 minutes? About how much the temperature was? It's between 20 and 30.
So maybe 25.
Yes, 25, 26 degrees Celsius. Very good. Okay,
Yeah.
thank you. Adham, are you there? Adham?
Yes, miss. Yes, miss.
Yeah, okay. The fifth reading, Adam, the fifth temperature was taken at what, after how many minutes?
10, 50 minutes.
Excuse me? The fifth reading. The fifth reading. Now I want to know when did they take the fifth temperature of the drink? After how many minutes?
Doesn't make sense.
What does that mean? What doesn't make sense?
Don't understand.
What? Yes, when did they take the fifth temperature? Look at that, dear. That was the first temperature. This is the second temperature. This is the third temperature. This is the fourth temperature, and this is the fifth temperature. The fifth temperature was taken after what?
And then 20 minutes.
At what?
120 minutes.
Yes. After 120 minutes, which means 2 hours. After 2 hours, they took the fifth reading. And what was the fifth reading? What was the temperature after 2 hours, Adham? Around 20 or 21, maybe. Is it at 20? Yes, or above 20 a little bit.
21.
Yes, it's 21 degrees Celsius at 120 minutes. Okay, thank you, Adham. And so on, guys, until we reach 210 minutes, okay? So the next question is, the next question is, after how many minutes did the drink stop cooling down? After how many minutes did the drink stop cooling down? So when you look at the graph, you're looking at the temperature or the time that the drink or the graph it stopped going down even more. It starts to form a straight line because this means that it's not, the temperature is not dropping anymore. So this means, Ahmed Hatem, when, after how many minutes did the drink stop cooling down?
Okay. 120.
I think it's after 150. It stopped
No,
cooling.
it's 150. Yes, it's 150.
Yes, exactly. So the answer is 150. After 150 minutes, the drink stopped cooling down. The next question, explain why the drink stopped cooling down. Huh. Now let me give you a hint, all right? I said that the temperature or the heat flows from the hotter object to the colder object, right?
Miss,
Yes.
me again?
No, I'm asking all of you. I said that the heat flows from the hotter object to the colder object, right?
Yes.
Okay. Until when? When will it stop flowing? I want you to think about it for a while.
I know.
Okay, Mira, when do you think it will stop flowing from the hotter to the colder object?
I think in 210.
No, I don't need a number. I don't want a number. This is not related to this question. This is a general question that I'm asking you. The heat keeps flowing from the hotter object to the colder object until when? When will it stop flowing? Apparently, it will stop flowing at some point. It will not keep flowing forever.
Yes, because the temperature is decreasing.
So? Okay, guys, I want you to pay attention. Now, the temperature will keep flowing from the hotter object to the colder object until both of the objects have the same temperature. Do you understand?
Yes.
Now they are balanced. None of them will be able, none of them is hotter than the other. Both of them are equal in their temperatures. So how will the temperature flow? Okay? So in this case, in the case of the mugs, you put the mug in a room. Okay? You put the mug in a room. And then the heat temperature, or sorry, the heat energy will start to flow from the hot drink inside the mug to the surrounding air, that is inside the room. Okay, because the air is colder than the hot drink. Do you understand so far, guys? All of you, I want all of you to tell me whether you understand or no.
Miss, can you please say it again because I was disconnected?
Okay, so again, the heat energy, or yes, the heat energy keeps flowing from the hotter object to the colder object. But this is not going to go forever. It will stop at some point. Why? Because the heat energy will keep flowing from the hotter object to the colder object until both of the objects have the same temperature. It will keep just flowing. The heat keeps flowing from the hotter to the colder until both of them will have the same temperature. Now, none of them is hotter than the other. So, of course, no heat will flow. Do you understand, Ruqayya?
Yeah.
Yeah. So now we reached a balance. Now this object has the same temperature as that object. Okay? In this question, in worksheet number 10, we poured a hot drink inside a mug. All right? Now, the hot drink is hotter than the room temperature that you put the mug in. Do you understand?
Okay.
Okay,
Yeah,
so now you have a
understand.
hot drink in the room that you're sitting in. Of course, the hot drink will be hotter than the surrounding air, than the air in the room that you're sitting in. So how will the heat flow from where to where? Hey, Ruqayya. Ruqayya. Did she disconnect again?
Miss, can you hear me?
Now I can hear you, dear. Huh? So how will the heat flow from where to where? You have a hot drink in a room.
Okay.
So it will flow, the heat will flow from where to where? Huh? Ahmed Ahmed. Ahmed Ahmed. Guys. Hello, can you hear me?
Yes. Yes, we can. Yes, Miss.
Now, what's wrong with the people? I'm asking a simple question.
I don't know.
You have a hot drink in a room. A hot drink surrounded by the air of the room that you put the drink in. So how will the heat flow from where to where?
Miss, I'm raising my hand.
Okay, Mira, tell me.
Miss.
Huh?
Yes.
From where to where?
The air will go like will
the direction of the heat flow, Mira. In simple words, please. Do not think about it a lot. You have a hot drink. You have a hot drink and the surrounding air of the room. The heat will flow from where to where?
Air resistance.
What air resistance, dear?
Can I say it?
No, just 1 minute. Air resistance, where did you get this answer from? Is that the force lesson or it's the heat lesson?
It's the force.
Yes, dear. The heat in general flows from what object to what object? From what? Dear, honey, I was just saying it right now. From the hotter to the colder object. Is it so hard? Guys, seriously, I need you to pay attention. Please focus. Please focus. I'm not taking extra sessions and making all of this effort for you to just, I don't know what's happening. Mira, are you there?
Yes.
Okay, so the flow of heat from where to where?
From the cold stuff to the hot stuff.
From the cold to the hot.
Yes.
Are you sure? So the cold
From the hot to
stuff,
the cold.
the cold
No,
stuff
from the
have
hot to
more heat
from
energy
the hot to the
than
cold.
the
From the
hot
hot to the
stuff.
cold. From the hot to the cold.
Okay, very good. So the flow of energy is from the hotter object to the colder object, right?
Yes.
Okay. So in this question, you have a cup full of hot drink.
Okay.
Okay. And you put it in a room surrounded by the air. Okay. So my question is the room temperature hotter or the hot drink hotter?
The hot drink.
Yes, of course. You're sitting in your room drinking a hot chocolate, a mug of hot chocolate. Do you think that the room that you're sitting in is hotter than the hot chocolate that you're drinking?
No.
Of course not. So now you have a mug full of hot chocolate in a room. So this means that the hot chocolate is hotter than the room, right?
Yes.
Okay.
Yes.
So this means that the heat will flow from where to where?
From the hot to the cold.
What is hot in this case?
The mug. I mean the drink.
The drink is hot. To what is cold in this case?
The air.
Thank God. Does everyone understand?
Yes.
Yes.
Is it clear now?
Clear.
Okay.
Yes.
Miss, the time of the session has finished.
We have another session, Adham. Don't worry about this. Okay? So now my question is, you said that the hot drink will keep flowing its heat to the cold air. Correct, Mira? You said so, right?
Yes.
Until when?
Can you say it again?
The hot drink, the heat will keep flowing from it to the air of the room, right?
Yes.
Until when? When will it stop? The heat will stop flowing from the drink to the surrounding air.
When the drink gets cold.
Yeah, when the drink and the room temperature is the same. Yes.
Oh, yeah.
Okay, when the drink and the room temperature is the same. At this point, the heat will stop flowing from the drink, and both the drink and the room, both their temperatures will be the same. So at this point, the hot drink will stop from getting cooled down. So the question is, explain why the drink stopped cooling down. Ali.
The drink cooled down. The drink cooled down because it reached the temperature of
Stop cooling down. Ali. No,
the drink stopped cooling down because it reached the room's temperature.
Thank you so much. This is exactly what I want you to tell me. The drink stopped cooling down because it reached the room temperature. The drink stopped cooling down because it reached the room temperature. At this point, both the room and the drink will have the same temperature. So no one will be hotter than the other. Both of them will have the same temperature. So the heat will not be able to flow from one object to another. The heat will flow only if one object is hotter than the other. Is it clear for everyone?
Clear.
Yes.
Okay.
نفسك عشان انت بريدي اكتر مني انا.
Oh, mute your mics, guys. So explain why the drink stopped cooling down. Because it reached the room temperature. All right? Okay, I'm going to end this session and I will start the new one.
Okay.